So, hello, my name is Nazar Bobyliak. I'm a third year student of system analysis, and today I will talk about sentiment analysis on movie reviews. So, first of all, I will tell you about what is exactly sentiment analysis and why we need it and what purpose of using it for film reviews. Also, I will tell about problems of system analysis of text and main features and models that we are used to solve this. And last but not least, I will tell you about my dataset and what I have to do with it. So, sentiment analysis is an NLP technique used to determine whether the given data is positive, negative, or neutral targeted. Sentiment analysis is extremely important because it helps business quickly understand the overall opinions of its customers. By automatically sorting the sentiment behind reviews, social media conversation, and more, you can make faster and more accurate decisions. So, what is the purpose of sentiment analysis in movie reviews? Movie reviews help users decide if the movie is worth the time. A summary of all reviews for a cinema can help users make the decision by not wasting their time reading all reviews. Movie rating websites are often used by critics to post comments and rate movies, which help viewers to decide if the movie is worth watching. Sentiment analysis can determine this attitude of critics depending on the reviews. Sentiment analysis of a movie review can rate how positive or negative a movie reviews and hence the overall rating of a movie. Therefore, the process of understanding if a review is positive or negative can be automated as the machine learns through training and testing data. So, the next thing is obstacle in sentiment analysis. Sentiment analysis is one of the hardest tasks in natural language processing because even humans struggle to analyze sentiments accurately. So, there are two types of text, subjective and objective. Objective text do not contain explicit sentiments, whereas subjective text do. In this example, we have the package is nice and the package is red. For most people, the first one is positive sentence, and the second is more neutral. This is because the word nice is more subjective than the word red. So next, when it comes to irony or sarcasm, people express the negative sentiments using positive words, which can be difficult for machines to detect without having a thorough understanding of the context of the situation in which a feeling was expressed. And about neutral, defining what we mean by neutral is another challenge to tackle in order to perform accurate sentiment analysis. As in all classification problems, defining your categories and in case the neutral tag is one of the most important parts of the problem. What you mean by neutral, positive or negative does matter when you train sentiment analysis. Since tagging data requires the tagging criteria be consistent, a good definition of the problem is a must. How should we approach transforming word presentation to numeric version that the model can interpret? There are many ways, but for now let's try a few of the simple approaches. Back of words. We obtain the vocabulary list from a whole text dataset. The length of vocabulary list is equal to the length of the vector that will output when we apply back of words. For each item, could be an entry, sentence, or a line of text, we transform the text into frequency count in the form of vector. We code this by setting up a count vectorizer fit it on the training data and then transform both the training and test data. Next, we have TF IDF. This is short for term frequency inverse document frequency and give us a measure of how important a word is in the document. Term frequency same as back of words. It is number of times term appears in the document divided by total number of words in the document. The inverse document frequency measures how rare a term is across all documents. The higher the value, the rarer the word. So it is natural log of total numbers of documents divided by number of documents with term in them. And we combine them to get TF-IDF as follows by multiplying it. So now we will talk about modeling. We attempt two different models for the dataset, naive Bayes and random forest. Naive Bayes builds on Bayes theorem, while a random forest is a group of decision trees. So let's talk more about naive Bayes. This is a probabilistic machine learning model used for classification based on Bayes theorem, and where B is an evidence while A is a hypothesis, we must assume that the features are independent, so that our model is working correct. And next is random forest. Random forest is a series of decision trees in which the leaf nodes indicate the predicted class. Each decision tree incorporates a selection of feature and outputs the decision at the end. These results are then combined from all of the decision tree to give the final class prediction. And then we have my dataset that I found. My core dataset contains 50,000 reviews split evenly into 25,000 for train purposes and 25,000 for test purposes. The overall distribution of labels is balanced. That means that 25 of my reviews are positive and 25,000 are negative. Also, in addition to the review text files, there are already tokenized back-of-word features. This means that after I pre-processed my data, I will build naive Bayes and random form models using the given back-of-words and compare the result. Also, there is a paper with classification result which I can compare to also. So the aim of the work is to build models for sentiment analysis based on the selected dataset by several of the above methods and compare the results.